Hello, it's JT, and in this video I will be giving you the basics on absorption. So what is absorption? Absorption is a surface phenomenon in which molecules, ions, or particles from a gas or liquid stick to the surface of a liquid or solid material known as an absorbent. This process is due to attractive forces between the absorbate, which is the substance being absorbed, and the absorbent surface. Be careful to note the difference between absorption and absorption, as the latter will have the particles soak into the other phase, while absorption will have the particles stick to the surface of the other phase. And you can see in this picture here the difference. So we have two main types of adsorption, which is physical and chemical. Physical absorption is a process in which molecules or atoms from a gas or liquid are attracted and adhere to the surface of a solid substance through weak non-covalent forces. These forces primarily include the van der Waals forces, also the London dispersion forces, dipole-dipole interactions, and hydrogen bonding. Chemical absorption is a process in which molecules or atoms from a gas or liquid are attracted and adhere to the surface of a solid substance through chemical bonds. So, physical absorption is using, those weak non-covalent forces, while these are more of chemical bonds, chemical reactions. So in chemical absorption, the molecules or atoms that are sticking to the surface undergo a chemical reaction with the atoms or ions of the solid surface. This typically involves the sharing or transfer of electrons between the absorbent and the absorbent, resulting, as a result of these chemical bonds forming, the absorbent becomes strongly bound to the surface. So next I want to talk about the four important absorbents that have the most application in the engineering industry. So the one in the picture on the left there is known as activated carbon, also known as activated charcoal, and this absorbent is one of the most versatile and commonly used absorbents. It's a very porous form of carbon with a large surface area, which makes it highly effective at absorbing a wide range of organic compounds, gases, and impurities from both the liquid and gas phases. An example of what activated carbon might be used for is water purification, air and gas treatment, odor control, and also removal of contaminants like volatile organic compounds, chlorine, and heavy metals. So you'll definitely see these in like a lot of filters, as it's taking out like impurities. And then on the right, a picture on the right there is silica gel, which is also a really highly porous but is also an amorphous form of silicon dioxide. Um, it is known for its exceptional moisture absorbing capacity, which makes it a very popular desiccant in applications where humidity control is vital, such as packaging, electronics, and preservation of sensitive materials. You've probably seen it. It comes in like those little packages and like your shoes or you know, for those who are into like computer parts, it probably comes in like your computer parts also. Just to be like a moisture wicking type of uh thing, I guess. um, but silica gel is also used for absorbing various polar and non-polar compounds from gases and liquids. Um, and yeah, there are two more. I said four, but you only see two on the slide. But there are two more, which is activated alumina and molecular sieves. I think that's how that's pronounced. Um, but for the sake of time, the the explanations would make this video a little bit longer than it needed to be. Um, so I cut those out, but they're basically, they function the same, except they're just made out of different materials. Next, I want to talk about absorption equilibria. And absorption equilibria describes the balance between absorption and desorption that occurs naturally during the absorption process. And basically, it helps us understand how absorbent molecules interact with absorbents or the absorbent's surface under specific conditions, basically describing the natural state of the system when absorption and desorption reach an equilibrium. And lastly, for this video, I wanted to touch on refrigeration. Refrigeration in absorption refers to the process of restoring the absorbent material, kind of like what I mentioned earlier with the silica and the activated carbon, to its original or reusable state after it's been used to absorb substances. So, regeneration typically involves treating the spent absorbent to remove the absorbents that have accumulated on its surface during absorption. And we have three types of regeneration: thermal, purge, and solvent. So in thermal regeneration, the absorbent is heated to a high temperature, which causes the absorbent molecules to desorb, or I guess release, from the absorbent surface. Purge regeneration involves clean gas passing a gas, which is oftentimes heated or at a specific pressure through the absorbent material to remove the absorbed substances. And then in a solvent regeneration, a suitable solvent is used to desorb the absorbent from the absorbent. Basically, in all these cases, the absorbent is captured and potentially reused. And that is the end of this video. You're probably thinking, really? No equations, JT. Where are the calculations? But fear not, my fellow classmates. I will go over that in my next video. See you all in the next one.